Relationship between two categorical variables. So that's what we're starting with here in the unit 2. This is kind of a shorter unit, not too bad. It's gets into some stuff you know and some stuff you're going to learn for the first time. Today you might know some of this stuff. Uh, what are the two variables we want to analyze? So you want to analyze a response variable and explanatory. Okay, so think about, I don't know if you do this in science class, but which one's the explanatory? So if you're having trouble remembering, I'm going to write it a different way. Explanatory. So I'm emphasizing the X part of that. So your X-axis is the explanatory variable. It explains or predicts the Y variable, which is called the response variable. One thing that I like to think of the response variable is something usually that you measure. So you might be choosing different octanes of gasoline or something here as your explanatory variable. Maybe you're measuring the mileage that you're going to get, how many miles you get per gallon or something on the y-axis. You're measuring the response. So we choose the explanatory. Usually we measure the response, and so that's what that is. And this is what they kind of said. Can you identify it? So the weight in carats and the price in dollars of a sample for diamonds. So which one would predict the other one? So to me, this seems more obvious. Probably it's going to be the weight, how much a diamond weighs is going to predict the price, or we can measure the price at that point. It just seems to make sense. Okay, hair color and eye color. So which one is the explanatory? On this one, I don't know. I mean, I think it could go either way. Maybe a lighter color eye might indicate lighter color hair, or is it hair indicates eyes? I don't know. I don't know. I mean, that one sometimes it's not obvious, and so there's no right answer. You would just have to choose, I guess. We already did that one. Two-way table. This is something I think you've probably seen, at least on the ACT, that summarizes data. So this is what a two-way table might look like. So a typical starting question might be just something like, what percent of people in the sample? So when it says it that way, people in the sample, so we're choosing, that's everybody, right? Everybody in the sample. And you can see in the bottom right there, that number 1526, that's everybody in the sample. So that's my denominator. It's kind of like probability. What's the numerator going to be? We want to sample all the environmental club members. So how many environmental club members are? Yes, there are 305. So your fraction would be 305 divided by 1526, which is 0.2. Because they asked for percent, I would probably write it like 20%. What proportion of people in the sample, again, out of everybody, the denominator is going to be 1526. Who are we looking for? People who have never used a snowmobile. So never snowmobile is 657. So that would be the answer. And when it says proportion, either one's okay. Fraction, decimal, we're fine. Marginal relative frequencies. So this is, I think that one was, those are marginal because we're using the margin. So the totals there on the right and the bottom there, those are marginal. So they're margins, so they're totals. So that just means you're using the totals to get the answer, right? I think it's the kind of relative frequency means percentages. So if we make everything percentages, so let's see what happens here. So what is the distribution of environmental club members? So environmental club members have two different types, right? Some people are members and some people are not members. But you're looking for marginal, in this case, the total of each. So how many yeses and how many nos, what proportion of the total? So nos, 1221 out of the total, and yeses, 305 out of the total. Those are the marginal frequencies for all environmental club members. So it's just taking that category and breaking it down to both components. We could do the same thing for snowmobile use, except there'd be three components, right? There'd be the nevers, the rent, and the owned folks. And we take the marginal frequencies of each. So you could, what percentage of people in the sample are environmental club members and own snowmobiles? Now here's a little different kind of question. So again, percentage of people in the sample, out of everybody, that's the denominator. But who do we want? We want an and here. So we want yes to environmental club member, and own. So there's only 16 folks that fall in that category. So 16 out of 15, 26. What proportion of people are not environmental club members and have never used snowmobiles? So not club members, so no, and never used snowmobiles. Both those things have to be true. Only 445 people does that apply to out of everybody again. Joint, again, it's an and statement there. We're doing two. And joint relative frequency would be when it's all percentages, right? So that really makes it nice to use, easier to use the chart when it's all percentages. But there's something about, we usually see these as counts here on the left, but we could convert all these to percentages individually, just like we've been doing actually. This is a two-way table with frequency counts, two-way because it has two variables, and a two-way table with marginal relative frequencies. So conditional, I really like conditional. You kind of get used to it after a while, just the way that the question is phrased. So what percentage of, now it doesn't say of everybody, of the environmental club members. So given that you're an environmental club member, that's how many people are we talking about here? We're talking about 305 people. We don't care about the no's, we care about the yeses here. So of those folks, how many are snowmobile owners? There are 16 of the 305, so that would be 5.2%. Or what proportion of the snowmobile renters? So we only care about the renters now. So see the renting row. There's 574 people total. That's my denominator. Are not environmental club members. There's 497 of those guys. Okay, this is from the Titanic in 1912. This is information about the different classes of passengers, first, second, and third class. Those who travel to different classes there, and whether they died or survived the Titanic. So what proportion of adult passengers, so that's out of everybody, 1,207 passengers, survived? It's kind of a small ship these days. I think I was on a cruise ship with more people than that. But back in the day, that was really big, I think. So what portion of adult passengers survived? So that would be 442 out of the total of 1,207. It's a marginal relative frequency. Marginal because it's in the margins there, and relative because it's percentage. Traveled in third class and survived. So third class, so this is conditional, right? Conditional saying how many third class folks? 627. How many of those folks survive? 151. So that's, oh wait, what percentage of adult, I'm sorry, what percentage of adult Titanic passengers, so that's out of everybody, in third class and survive? So that's, again, one of those joint ones where it's third class and survive, which would be 151 out of the total there. It's a joint. Sorry, this one is conditional, I believe. What proportion of survivors, so of the survivors, 442, were third class? So 151 out of the 452, 442. And then finally, what percentage of third class survived? So of the third class, those two questions look awfully alike, but they're different because they're different conditions. This says of the third class, given that you're third class, well, there's only 627 of you. How many of those folks survived? 151. So it's a different question. It depends what's the condition or the given statement. Out of what group are we picking from, so to speak? Okay. We're comparing different sizes. Usually the graph on the right's a little better because relative frequencies are a little easier to use because the straight up numbers can be confusing. And it shows better, especially when the groups are unequal sizes. It just gives you a better proportion there. Now you see the proportion there is 36% for the number on the left and 69% for the number on the right. So percentage-wise of those groups, it's quite deceiving just to look at the numbers. But 212 is a large proportion of the yeses. 445 is a smaller proportion of the no's. So if you look at it that way, it's kind of confusing numbers because it looks like 445 is the bigger number, but percentage-wise, for what they might be asking, it could be the smaller percentage. So again, use precise statistical language when you're describing these for sure. Segmented bar graph. Now this one, I don't know if you've seen before. I think you've probably seen a two-way table before, but this one, I don't know. You've probably seen the graph on the left there. That's just a side-by-side bar graph. But in AP Stat, we like to sometimes make, we stack them, a segmented bar graph. And it literally is stacked. So you see that green bar on the left is, I don't know, 25%. The green bar on the left on the segmented bar chart is also represents 25%. It's hard to count the 25%. But if you stack those three bars on the left to the first bar on the graph, the right graph that's stacked there, you can see that it's the same three size stacks, so you just stacked them up. And you can easily compare from the no's to the yeses now. I can see that there are a lot more yeses than no's. It just stands out a little bit more. There are a lot more owns on the no's than owns on the yeses here. So it compares different things. Whereas the graph on the left more compares within each no, and within the yeses it compares a little better. So just kind of whatever floats your boat. So that's a segmented bar graph. This is called a mosaic plot. It's kind of interesting. It's similar to a side-by-side bar graph, but the width tells you the amount, like the proportion, I guess I should say. It doesn't tell you the amount. We don't know. We can't tell if there's 1,000 people or 10,000 people here. We can tell that there were a lot more no's than yeses. So if you look back at the data here for a second, you can see there are 1,221 no's and 305 yeses. There are a lot more people that are not members of the club than are, right? So that's what this graph, the mosaic, unlike the segmented bar chart, which doesn't tell you anything about how big each group is, this one does. It gives you more information. So the width is proportional. I can see there's about probably four times as many no's as yeses here. So you can kind of tell the proportion. Still can't tell the numbers, but you can tell the proportions comparing to each other how many members and non-members there are. So again, the one on the left doesn't show as much information as the one on the right. That's a mosaic. They had one of those on the most recent AP exam, actually. So could you construct one? So if you want to identify the variables, draw and label the axis. In this case, so you're going to make class of travel that makes sense to be your explanatory here, kind of. You're predicting whether you survive or not by the class, and actually I think first class you have a better chance of surviving. Percent is always going to go to 100% for a bar graph like that. In fact, for a segmented bar graph like this, you just draw the 100% bars to start with, and then you break it down. You figure out how many survived, how many didn't, and so you segment those by getting the percentages, and then you draw the segments. And preferably, this is a good time to use different colors. You don't have to. Some people shade inside one and not the other or something. The idea of it. And you can see like, oh, that's really stark there. So the first class, you have a more than 50% chance of surviving. The third class, ooh, not as good a chance. And this also gives you more perspective of how many third-class passengers. There were many more third-class passengers. There were not as many second-class passengers. You can tell from the width there for a mosaic plot. There's an association between two variables if knowing the value of one variable helps us predict the value of the other. Okay, so like this one, if you are a yes in the club, you're much less likely to own a snowmobile. So I would say it's predictive. There is an association between the two variables because it just does. Now, yes, there is a clear association because of the differences. What would it look like if there's no association? So what would that graph look like? It would look like that, right? So if they were exactly the same or pretty similar, then you might say, oh, there doesn't seem to be much of an association here because I can't tell. I can't make a prediction if they're yes, they're in the club, they're not more likely to, own a snowmobile or something. They seem to be about equally likely. This one, is there an association between class of travel and whether you survived or not? Yes, there's a clear association, right? For sure. Okay, that's your lesson for today.